So in a given problem, he has given a 200 volts shunt motors which draws a current of 20 amperes at rated voltage and which is running at 1000 rpm, and he wanted to reduce the speed to 750 rpm. That will be done by inserting an external resistance in the circuit, and he is asking what is the value of resistance required to connect it in the armature so that the speed will be reduced to 750 rpm. Okay, and also he has mentioned the load as a fan load, which is very important. So a fan load means, so in case of a fan load, the torque is proportional to speed square. So torque means phi into Ia is proportional to speed square. Since it is a shunt motor, so the flux is always a constant value. So that means armature current is proportional to speed square. So is mentioned what is the change in speed, so you find out the change in current. So once you find out the change in current, you can find out the resistance. So first of all, I'll find out the value of current at 1000 rpm, because he has mentioned the line current has 20 amperes. So in order to find out the armature current, which is nothing but the line current minus shunt current, so I have to find out first the shunt current. Shunt current, if you see here, it is a 200 volts, and the field resistance is 100 ohms. So this 2 amperes is the shunt current. So this is 20 minus 2, so 18 amperes when the machine is running at 1000 rpm. So now you find out Ia2. So from this, what I can write, Ia2 by Ia1 is equal to N2 by N1 whole square. So this implies Ia2 by Ia1 is equal to change in speed, that is change in speed is 750, the original speed is 1000 square. So from this we can find out the current. So if you find the current, this current will be Ia2. If you simplify this, you get 10.125 amperes, because Ia1 is given as a 18 amperes. So once you find out Ia2, we know that the speed is proportional to back EMF. AB is proportional to back EMF. Sorry, back EMF is proportional to speed. So N2 by N1 is equal to EB2 by EB1. So this implies 750 by 1000 is equal to, so EB2, that is supply voltage minus the current which we already calculated, that is Ia2. Ia2 is 10.125 into the armature resistance is already 0.1, and you are going to insert a resistance R divided by, this is 200 minus armature current is 18 initially, so this is 0.1. So here the only unknown is R. So if you simplify this, you will get a value of R which is equal to 4.97 ohms. So from the given options, the answer is 4.9 ohms.